Okay, this is my business, which I set up 23 years ago. I'm a microbiologist by training. Water, as I think the Tamera community has found over the past 5 years, is the basis of life and the driving force of nature. And that was Leonardo da Vinci said that, so we can't disagree. However, fresh water is a minute proportion of the water on the planet. So it's our duty really to conserve and to look after it and to use it wisely. This is some figures just showing what form this water is, and it's from the Permaculture Designer's Manual. So this is where this water is on the planet, and most of it is locked up or is unavailable to us or is salt water. So it's a tiny proportion of water that we are actually allowed to play with. And it's the primary resource for life. Without water, we have dust and no productive capacity at all. In the water cycle, when water is allowed to do its duty in the landscape, it is the basis of our production and our purification systems. And that is what I use in my design work at Biologic Design. And all of the work at Biologic Design is based on the permaculture design principles and P.A. Yeoman's keyline system. The basis of my constructed wetlands for wastewater comes from P.A. Yeoman's work using swales to harvest rainwater on a landscape level, which is what you're starting to do here, to create living soil. And a swale is very simply a ditch and a bank that runs along the contour of the land, and therefore as water passes from higher in the landscape down the land, falls from the sky, it's trapped and held high in the landscape where it can do its useful work. By infiltration, recharges groundwater. And trees and other fibrous rooted plants are an integral part of a swale in enabling it to function. So this is a P.A. Yeoman's farm that he tried this work out on, first of all. You can see there's a series of contours with the highest point being on the left and the lowest point being on the right. And each of those lines goes down about, I think it's about 10 metres. The swales are created along the contours, and at the end of each swale there is a pool, a reservoir created by a dam. The water comes into the swale, fills the pool or the reservoir, then overflows to the next swale, which then fills that swale, fills the next pool, and so you're retaining water on the landscape. And Yeoman's idea was to drought-proof farms in the brittle environment of Australia, where they have sort of 7-9 year cycles of drought and flood. And his idea was to drought-proof these farms. Okay, a reed bed is, in my view, a chemical engineer's idea of what a natural wastewater system should be. It's basically a swimming pool, a shallow swimming pool, maybe 1 metre deep, full of gravel, with one species of reed growing in it, Phragmites communis growing in it. And 35 years ago I came across reed beds and I thought that's the way to do it. And then after 10 years in the conventional waste treatment industry, I was given the opportunity by the company I was working for to create some reed beds. And it was a 5-acre reed bed and a 7-acre reed bed. So these are large reed beds. And of course I was over the moon. I was thinking, this is great, I'm doing natural wastewater. And that sort of feeling of elation lasted probably about 2 weeks. And then I was actually on site, and I was watching these 40-ton trucks coming in day after day after day, dropping tons and tons of gravel into these concrete-lined chambers. And then we were putting literally miles and miles of plastic aeration and distribution pipework into these reed beds. And I realised, simply because of the scale, that this is not ecologically valid. There's a huge embodied energy in digging up the gravel, taking it across the country, dumping it down. I then obviously looked into reed beds more fully and realised that actually reed beds clog up after 3, 4, 5, maybe 10 years because of the microbial sludge which develops in the interstitial spaces between the gravel. There are little spaces Also, the biological activity is only on the surface of the gravel particle. Whereas if one used a soil-based system, the particles are much smaller, and the roots going into the soil actually open the soil and allow the passage of water. So, taking P.A. Yeoman's keyline system and swales, taking permaculture design principles, putting it together with my own knowledge of how conventionally we treat waste in machines, which use huge amounts of energy, I thought, what if we use these swales to harvest wastewater instead of rainwater, and we create a multi-species system based on soil, not on gravel? Surely that would be better. Then we could have a system that was actually not just purifying this problem, but was creating a lovely ecosystem, a wetland ecosystem, great for wildlife. We could also have a productive system that, instead of just getting rid of the waste and purifying the water, was producing purified water and the potential to create resources. And I thought, that's probably the way I want to do it. And that's when I set up Biologic Design with the theory in my head and had to then prove it. Now, since 1992, I've done just about 200 wet systems in a whole range of scales for a whole range of different applications. So the wet system looks at waste not as a problem to be got rid of, but as a resource to be used. This picture shows, at the point this photograph was taken, it was a 13-year-old wet system that is dealing with the wastewater and runoff from a dairy farm with 350 cattle. There are 2.5 acres of dirty yard area. It's not dealing with the solids get scraped and then spread on the land, it's dealing with the dirty water. And the reason that the farmer had to have this system is that he was in what's called an NVZ, a nitrogen vulnerable zone. And if he polluted the rivers, he would be in line for a large fine. So instead of paying the large fine, he decided to put a wet system in. These ponds, for example, contain fish. And he lets, on day tickets, fishermen come in and fish these lakes. It's a 6-acre system. He also has deer come in from the surrounding woodland into the wet system to graze, and he has a high seat, and so he harvests the venison from them as well. There are also 35,000 willow trees, which can be harvested and chipped and used as bedding or as fuel. And there are 3,500 other trees, which are coppice trees, so they can be cut and they regenerate, and that's for firewood resource. So from his problem of the wastewater, he's now created a lovely ecosystem which is producing resources and protecting him for the next decades against the possibility of a big fine for polluting the local watercourses. He also said there's something else which is not in the brochure, so to speak. I was there about 2 years ago, and he said, I'm supplying milk to the supermarkets, and the buyers give me such a hard time. Every time they come or I talk to them on the phone, I get so angry. He said, and I go into the wet system, and I sit, and I listen to the birds, and it's good for my soul. So that's an added bonus. So here we have wastewater is not a problem, it's a resource. In the permaculture principles, there is no such thing as waste, just an unused resource. So a wet system can be described as a horizontal plug flow, soil mycorrhizal, multi-species purification and production system, or just a lovely wetland. People often think, oh, it's the plants doing the job, but it's not. The plants are supporting a whole plethora, a whole colony, a whole community of microbes in the roots, in the soil, and that is what is doing the treatment of the waste. But they're being supported and given oxygen by the roots of the plants who are photosynthesizing. And it's the processing ability of these microbes that enables the wet system to work. So here we have some of the willow varieties on a wet system. We have at the moment over 50 different varieties of basketry willow. So we have, as I said, hundreds of sites, and what we try and do is get local craftspeople to come in and harvest the willow for the client and take that resource, which is their livelihood, from what is our livelihood, making wet systems. And so there's a lovely idea of right livelihood, which we like to promote, that people are doing what they love using natural materials that are produced from what was previously called a waste. And this is some of the material, some of the stuff that is made from our willow. So the other thing about a wet system is it sequesters, it captures carbon dioxide through the photosynthetic process. It takes in CO2 and makes it into woody biomass, or soil as well. And each year Biologic Design plants between 5 and 100,000 trees. So we are basically a carbon neutral or even a carbon positive business. Wet system doesn't use gravel, as I said earlier, and neither did it use large quantities of pipe work. So we don't have that high embodied energy. In fact, the major energy input of a wet system, which stands for wetland ecosystem treatment, is the diesel fuel used in the initial earthworks. After that, it's solar powered and gravity fed, and it usually uses no non-renewable energy. This is the second wet system I did. And it was an 8-acre wet system for a cider mill in Herefordshire. This is now 23 years old. It's now dealing with almost 200 times the cider production that it was originally designed for. And we have, obviously we've made modifications over the years, but the other reason that this is so is because if you can imagine, we planted a tree which was no bigger than my finger, with no roots and no leaves. In the first year the roots spread and the leaves grew. We now have trees that are massive, and we planted 50,000 trees on this site. So imagine the root mass and the evapotranspiration and the number of microbes that are growing in this system. Each year gets better. So whereas reed beds clog up with time, and whereas machines break down with time, a wet system gets more efficient with time. This is a swale. We're now standing just behind the swale ditch with the reeds in, and then the swale bank is the trees that we can see behind, and the water is flowing away from us, so into the wall, so to speak. I like to think of myself as a bioengineer. So in using biological systems and components to carry out engineering functions. And the main functions that we're looking at are wastewater purification, odour control, and soil stabilisation. And it's just some of the species we use, as well as the 50-odd varieties of willow which we use. We also use this. This is something called Glyceria maxima, reed sweetgrass. Far, far better in sewage systems than Phragmites. And the lovely thing about Glyceria, apart from the fact that it's edible from stock, so you can use it as a stock feed if you want, is that it has a habit. It grows up and then it flops down. And as it flops down, every leaf node sends out a root and a shoot. So after the first year, you have what we call a redraft over the whole surface of the inlet, which prevents odour and actually enhances the purification process. So it's looking at what this plant will do and using that in our design, which is a permaculture principle. Observe nature, let nature be our teacher, and we can then use that, what it wants to do, to help our process. This is hemp agrimony, or Eupatorium cannabinum, which is a fantastic soil stabiliser. So later on you'll see some earthworks we do. We go in with a whole bunch of seed and we throw this seed about, and part of the seed is this hemp agrimony, and that stabilises the earthworks so they don't get washed away. Because one of the problems when you're creating banks of topsoil is if you get heavy rain, it can be washed away before the soil has been stabilised by the plants. This is another thing we use for redraft. This is a greater willow herb, which can handle its roots being all the time wet, and we can seed into acidic waste. If we're using wet system, say for cider mills, we observe that this stuff seeded into the inlet, which has a pH of about 3.5. So it's not quite battery acid, but it's pretty close. and it has a BOD, a strength of between 5,000 and 7,000, and sewage has a BOD, a biological oxygen demand, of about 350. So it's very, very stronger and much more acidic. This stuff thrives in that situation, so we see that, we now use it to create a redraft over cider effluent to prevent the smell. So here are some of what I call my willing workers. These are some of the fungi and some of the microbes and slime molds that exist at the western site, and these were all taken the same day, just walking around, seeing some of the fruiting bodies, some of the mushrooms and toadstools that exist. And they're all working away 24 hours a day, 7 days a week, no holidays, no pay. It's brilliant. Now this is a summer photograph of a system that deals with up to 1,500 people, and sometimes there's nobody there, and they have a shower block, toilet block, a kitchen, and sometimes there's 1,500 people there. Now reed beds do not like that sort of change in the input, whereas wet systems can handle that variability in loads. This is the summer picture, and then almost from the same position there's the winter picture. And you can see there are clumps of willow. And this willow is harvested each year by the 3 guys that look after the site and are sold to a local hurdle and basket maker. And this system has been in place for about 15 years and has paid for itself simply selling the willow. So, a wet system is a wastewater purification system created and planted specifically to provide not only clean water with minimal or no non-renewable energy, but also to produce a useful economic yield. So this is a picture taken last year of a wet system we created less than 9 months beforehand for a Buddhist community in Herefordshire. It deals with 50 people all the time, and then once a year they have a big international gathering, 3,500 to 4,000 people for about a month, and then every 3 months they have about 200, 300, 400 people come for retreats on the site, and they camp. So there's a huge variation in the wastewater going in. This has been planted with fruit trees as well as wetland trees and willows. So this is what we're looking at. So just bear this in mind when we go back in a minute to what the earthworks were like 1.5 years ago. It looks to me as if it's been there forever. This is some of the willow coppice, and this is how we started. So we had a bare field, fairly steep, arable field, ploughed to death, no mycorrhiza at all, totally thrashed ground. The nice thing about it, if there was a nice thing about it, is there were very few weed species because they'd all been sprayed out of existence. But there was no soil structure there at all. These are some of the pictures of the day we started the job. So again, we take the topsoil away, we create our swales using fairly big machinery. I mean, it could be done by hand, but it would take much longer. So we're working with the contours of the ground all the time, compacting it, the clay, subsoil, adding the topsoil back. And you can see it's a vegan community, and there's an incredible smell of onions in this. So this is, again, the water's coming into the top even before we finished the wet system. So this is the swale, series of swales going down the slope. You can see there's the banks and the pools, the potential pools. And this was with the 2 lakes at the top of the site. We were then bringing water in to fill up the rest of the pools below the one that had the sewage in from the inlet, so that we could plant it up straight away. So there we go, that's all the swales full and ready for planting. Then from a local wood which we manage, we were getting wood chip, which we mulch everything with, which stops weed growth, adds particulate organic carbon, so that helps absorb the nitrogen in the early days, and obviously rots down into topsoil, which is the basic purification medium of the system. So by adding the wood chip, and remember on this site, because it had been hammered by conventional agriculture, there was no real topsoil. So we added 6 inches of wood chip, and that's now rotting down to become the soil, which aids the purification. And this is the bunches of willow. So they're from my nursery. Each bag contains a specific cultivar of willow. So we plant groups of 100, 150 of the same sort. So if a basket maker particularly likes that one, they know they can go there year after year and select that one. And that's the inlet, probably about 4 months after the planting. And everything, the willows they're growing. And this is the Glyceria maxima, which I said forms this reed raft and stops that onion smell coming out. These are yellow flag iris, and we plant up to 45 different species of wetland marginal plant, and probably not all of 55 willows, but between 20 and 30 different cultivars of willow on every wet system. It's just to show the clarity of the water in the bottom pond. And this is less than a year after we started the earthworks, so it's the first growing season. That's what I was looking for. That is the inlet after the first growing season. This is the start of this year. It's totally covered with Glyceria maxima. Okay.